Okay, I got the technology sorted. We can start. So we had a short break from you. You had short break from me. I've been paragliding in Spain. So we've been collecting tracks for the system that we're working on. I can show you later some of the trails I've done. I beat my personal best of doing a 65 kilometers cross-country flight. So there were some questions about how to calculate the distance. So obviously calculating the distance for the flight based on the point. So if you start from one point and your GPS collects this point, and so on, so you have some sort of a path, right? And you ended up here. Adding all those little distances kind of makes no sense really, especially if you are a glider, because often what you do, you have to go in circles, right? You kind of go in circles to get up to the cloud base in the thermal. So adding all those distances kind of makes no sense, right? So in the exercise, we kind of adding all those distances, but as a kind of a simple metric for getting the length of the track. But in normal kind of in normal systems, what is relevant is the distance between the start and the end point. But that also is not as relevant as like how difficult the flight was, because if I take off in one spot and then land in the same spot, I covered zero distance, right? But I might have covered 300 kilometers along the triangle. So this distance between the start and end point is also not useful, right? So cumulative distance of all these distances is not useful. This distance is not useful. So what's useful? Well, there is a federation which calculates, which kind of sets the game of how, what is kind of nice. And the federation decided that there will be three main objectives. Okay, so you have you typically start in one spot. So you start somewhere and you get somewhere else, right? So this is called like a distance flight. So if you started in one spot and ended in the other spot, and you covered some, you flew and then you landed here, to make it kind of comparable between different pilots, you can only do 2 turn points. Okay, what does it mean? It means that we will calculate the distance, the best distance we can work out from this path, which only uses start, stop, and 2 points in the middle. Okay, so those 2 points in the middle, let's say I pick this point and this point, and those are called turn points. And I will calculate the distance between this point and this one and this one, and this one, and this one, and this one, right? The landing spot. And now those 1, 2, 3 distances will make my travel distance. Okay, so this is like the first task you may have for an open flight. So in an open flight, now if you have the trail, you have to work out which 2 points to use to maximize your distance, right? And that's non-trivial. It's kind of an NP-complete problem. Like if you have, 10,000 points, you have to check which 2 points to use for this calculation, right? And it takes a lot of time. There are some complex algorithms we could use, but generally it's quite complex to do this, right? So it was much simpler for the assignment to just calculate the other distance, right? What else? So this is the one where you fly somewhere else and you don't come back, okay? And that's the easiest. And in the game of flying, this is like 1 kilometer for 1 point, typically, right? It's the easiest. You just take off, you fly usually with the wind pushes you, so you get kind of high speed. And then you try to cover as much distance as you can, having kind of a 2 turn points somewhere along the way, okay? The other two are harder. So the other two is you take off, you fly, and you come back, okay? And you don't have to come back exactly to this, but depending on the competition, that let's say there is like a 5% rule that you have to, or 20% rule, you have to fly as close to the starting point as possible. And then what we count is, again, we pick 2 points, but we count a triangle, right? So we pick the starting point, we pick 1 point along the path, another point along the path, and we make a triangle, okay? And we count those 3 distances. And if the flight is, so this one was, let's say I flew like this, okay? If the flight is kind of flat, so I have 1 point here, 1 point here, and 1 somewhere here. So I will have like this. And you see that the triangle is very squashed, right? So the second is called flat triangle. Flat triangle. And this is usually 1.2 points per kilometer. Okay? So you get more points because it's harder to come back to the same spot. And then the final one is the holy grail, the best you can do. It's called phi triangle or balance triangle. So that's the one where you start, you fly somewhere else, and you fly back. And those three legs are roughly 33% each, right? So it's kind of almost the same distance between all 3 points. And this is like the most difficult one. And for this one, you get 1.4 or sometimes 2 points per kilometer, right? So on this last trip, I managed to do this one, which turned out to be 65 kilometers, and it's kind of double the point. So I got 110 points for the 65 kilometer distance, right? All those calculations are quite tricky. So you guys are not doing it, but you know, in the future, we will like to implement this. So some students or a master student will be kind of working on the more complex distance calculations, right? For the assignment, it was just trivial, yeah?
Do you care about the altitude of those?
No. So for the distances, only the kind of the flat drop of the ground is counted. Sometimes in some competitions they do. They set the limits of where you have to be when the start happens and when the stop happens. But yeah, generally for those kind of non-formal competitions, yeah, you don't. Okay, so what else is interesting? You probably checked that there are some so if I go to this one is a very useful portal. It collects data from all the IGC files that the people who are flying kind of generate, and it generates. So if I go where I was flying in the southern Spain in this area here, and you can see that I can check how did the previous pilots do. So for example, this is this is one of the main slopes that we start that we use. Let me just check again. Yeah, this one. So this one is called Lihar, and it has it's like 1,100 meters above the sea level, and the valley is about 400 or 500 meters. So you have 600 meters differential between the peak and the valley. So we take off either here towards the southern winds. So if the wind goes from south, you start here. If the wind goes from west, you start here, right? So if you know, those are the two spots where you start, where everybody starts. What happens when you start? Well, typically you go up because that's what you want, right? So you want you're waiting for the conditions for the thermal to come towards the hill and then kind of take you up. So if I put the thermal heat map, you see that those two spots are the hottest, right? That's where the most people went up. But that's kind of obvious. They have to go up because they're launching. Those are two launch sites, okay? Another launch site is here, and another launch site is here. Those here are not launch sites. Those are just hills along the routes which people use. So you can, for example, do a heat map of where the people travel the most. And you can see if you launch from the southern starting point, you can go towards the wind or against the wind, and usually people travel this way, right? So people travel kind of east, southeast, or southwest, or west, or east. If you get to here, you can see not many people travel this way. So to make a triangle like this way, it's kind of tricky because people travel this way, but not kind of on the triangle. The triangle I managed to do was go here, go here, go here, and go back. I actually did a square, right? I didn't do a triangle. So this data is based on the IGC files, and you can kind of calculate some of the interesting things based on the people flying. Another interesting thing which you can do is you can see, because the IGC file tells you whether someone was traveling straight in a kind of going down, going up, or circling in the thermal, right? So if you are circling in a thermal, that means that's a good spot for going up, right? We don't have engine, we don't have anything. So if you're flying, you have to have those up currents to get you up. And then if you leave it, you're going down, right? When you're flying, you're effectively going down all the time. So to be able to fly for 5 hours, you have to find those spots where you can go up to the cloud and then go down, and go up to the cloud again and go down. So if you analyze all those files, you can, for example, generate the hotspots. And the hotspots are where the most people went up, right? So you can calculate statistically that if you're flying, you see people flying southeast this way, along this path there is a lot of spots where people got the up current, right? So having kind of a repository for IGC files allows you to do this type of things, that you can calculate some statistics and calculate where is the probable place for you to find some updrift. So we will see. We will kind of keep working and building kind of a system like this. We have similar project with the master students, which are doing similar things to what you were doing in assignment 1 and 2. And then we will see what can be done. This has been done as a student project before in Switzerland. We can analyze, wind direction, or doing some interesting things with the data. Okay, so I've been going through some of the questions which we have on the issue tracker. I haven't covered everything yet. I've answered the README file. There was a question about the clock. I've updated the text for the assignment. The idea is that normally when you have your cloud system, it reacts to the user requests, right? It doesn't actually do anything on its own. It just sits there, and then if someone issue a query or issue a request, it triggers the processing and then sends the response, right? So what is the clock? The clock is some sort of autonomous piece of code which gets triggered internally. It's not triggered from outside, it's triggered from inside, okay? And you will have, if I go to the text, let me just go to the wiki. If I go to the assignment, assignment 2. So for assignment 2, we have now a simple text for the clock. And the idea is that every 10 minutes you will check if you have more tracks in your database than you had 10 minutes ago. And if you do, you issue a webhook to a Slack or to Discord, okay? You just notify on a channel or of some sort that, oh yeah, we have now 12 tracks, or we have now 16 tracks. If that number of tracks didn't change, you don't issue that. But every 10 minutes you do the check. And if the check tells you that the number is different, then you issue the webhook. It's the same as one of the webhook tasks, but the webhook task is triggered by the user, okay? So if the user sends a new track and someone is subscribed to the events about new tracks being added, then the behavior happens, right? So the difference between the clock triggering a webhook and the user triggering the webhook is the source of the action. With the clock, you kind of internally doing it. With the webhook API, you're doing it by the trigger from the outside, okay? Is it clear? You kind of understand it? I hope so. Kinda. So I will talk a little bit about the webhooks now, and we can come back to it later on, right? So one of the clarifications was about the webhook. The other clarification was about the cloud functions. So there was also a question about, where is it? Yeah. About that the ticker endpoint will be implemented as a cloud function. Well, you don't have to do it as a cloud function, okay? Again, we didn't cover the cloud functions yet. We will cover them later. The idea is that normally when you deploy on Heroku, you have kind of a semi-monolithic deployment of your app logic on a single cloud provider, okay? And sometimes it makes sense. Sometimes you want to be more flexible and you want to decouple it. So some of the endpoints will be handled by part of your system or part of the deployment, and some other parts will be handled by something else, okay? And splitting your kind of endpoints into the Heroku part and non-Heroku part sometimes might be useful. So those of you who want to experiment with it and have to use something else, you could, but normal, like if you don't want to explore it, you can just implement it as a normal Heroku endpoint, yeah? Yeah, so if you use the Heroku endpoints, you will be able to run them locally just fine. If you use the cloud functions, it depends. Most cloud functions, they don't allow you to test things locally. You have to test it with the remote service. So then there are some hooks attached, right? It's a little bit more complex to deal with it. Both logistically and kind of organizing your deployments and your code base as well, because you have to keep your code, which becomes your function, in separate place, because you're not deploying it to Heroku, right? So it is more complex. But in real life, often you do that. In real life, you often decompose more complex systems into sort of like modules or services which are independent of each other, and then you keep them separated, right? In this particular case, yeah, it doesn't make sense. Like if you were to be doing that system in production, you wouldn't be doing it as a cloud function because it kind of makes no real sense. But as a, as a playground, you could try if you want. All right, so I will address the other questions and issues as we move along. What we will do today, we will talk about webhooks, which is pretty straightforward topic, and also we will talk a little bit about MongoDB. MongoDB also is quite straightforward topic, but it's good to have kind of a hand-wavy explanation of some of the concepts. So we will cover those two topics today. I chatted with Christopher, and it looks like all of you have submitted the assignment 1, which is great. We will use a system which is based on peer review for reviewing the assignments, but I will explain it on Friday because we don't have the infrastructure yet for doing that. So once we prepare it, we will kind of discuss it. And we might use the Friday session for actually doing it. So whoever will show up on Friday can kind of use each other for doing the peer review. The idea is that you check somebody else's system and say whether they fulfilled the requirements or not. And then you put your student number into like a spreadsheet marking that it has been confirmed. And each of you will have 2 other students checking your work, and you will check 2 other students' work, right, to kind of balance it. The benefit of doing peer review is manifold. One is that we have less work because part of the work is done by you, which is great. Like if we have 90 submissions, it takes almost a week of extra hours per day to do this. If you just have to check 2 people, it's 15 minutes for you. The other useful thing is that you will see how other people did the task, okay? So you will learn how you can do it differently. You will learn from checking others people work, what they've done wrong, what they've done good, and you will learn by kind of observing how they coded the solution, how they split the app, and so on and so forth. So it's worthwhile. How they wrote the README file, how they documented it, whether they did the testing, and so on. So it's kind of a very useful to see somebody else's solution. And even discussing it before you submit is useful, right? We encourage you to work in groups and to discuss various solutions among yourself. It's like you learn by collaborating with others. You learn more by talking to others and collaborating with others than on your own. Yes, so I will kind of explain how it will be done on Friday. Yes?
Just a quick question with the assignment. If you fail it, is there a second-handed or is it just a one and done?
There is no second-handed, but you like if you did something, you will get some partial points, right? So it's not like it's 0 or everything. Like that's why we encourage you to submit even if you haven't completed everything. We will grant you some points for the assignment even if it's only partially done, right? There is no second-handed. And also the first assignment is kind of a prerequisite for the second one in a sense. They are linked, right? So even if someone didn't submit the first one, they will have to kind of do it for the second one anyway, right? So yeah, maybe it's a little bit unfortunate, but for those who did, it's kind of good because they can carry over the projects, right? So yeah, but I hope, yeah, I mean last year we didn't have much problem with that, so people who got partial credits for the first one catch up later. So we have 2 assignments, and the final one is a group project, right? And the group project is kind of worth the most of the internal portfolio. Yeah. Any other questions about the first assignment? How hard was it? How much time did you need it to spend? Some days. Some people like submitted the first assignment like 2 days after we announced it, right? It was not that hard for some people. I don't think it was hard, but there is a lot of new concepts and some new fiddling with Linux and so on. So
Like looking back at it, I wouldn't say it was all that hard, but like thinking back, like I spent a lot of time just understanding all the concepts.
Yeah, exactly. Yeah. So I think conceptually it's quite complex because there is a lot of things you have to take in, but actually doing the assignment is quite simple. All right, so let's talk about webhooks. So many things change. The concepts didn't change, but some of the examples that we use in the lecture did change. So I tried some of the examples that we've used, and obviously Slack and Discord are kind of the same. The webhooks work the same way, but we use Elastic.io last year, and this year they don't offer any free integration. You have to request a free trial if you want to. Otherwise, they only have paid plans. So yeah. So just for the sake of explaining Elastic.io. So Elastic.io is a kind of a cloud platform which allows you to plug in various cloud services together. So you can channel different events from different APIs to other APIs to kind of in a semi or fully automated fashion. So you may have some trigger from your Amazon infrastructure which triggers your email service with a mailing solution or with Twitter, or you may have some events coming from Twitter which trigger some, whatever. So a lot of services are out there. They have APIs, and if you want to link one API with another, you can do it manually by hand, or you can use solution like this, which kind of automates the pathways of events going from one system to the other. And we've used this as an example of webhook integrations, which channel some events or some triggers from your API towards something else. But this year you cannot use it. You have to send a request for a trial. Yeah. Anyway, where is the lecture? Webhooks. Yes. So. Okay. So what are the webhooks? I'm sure you've already used webhooks one way or the other. Or what are what are webhooks? Say it again. Yeah. So in a nutshell, it's a form of user-defined HTTP callback, right? I may have the simplest way to imagine it is you have a commit, you've committed something, and then GitHub triggers a webhook into Discord, which tells you that Mariusz made a commit, right? So on a public channel for the commits, you see a message saying, okay, an event happened. So I am generating the event by doing a commit, and then GitHub generates a webhook trigger into Discord or Slack channel and passes the message of the commit to that channel, and then the channel displays the message, right? So you can, but it can be anything. So it can be a trigger for doing a check. It can be a trigger for doing kind of a pulling the data from a service. It can be a trigger to record something or turn the heater on or whatever, right? It's basically kind of a user-defined way of initiating something, of triggering a remote endpoint. And what we do, we generally use REST API for this, same as with everything else. We usually use post and get methods, and the data being passed is usually either JSON or form-based formatted, right? Most webhooks these days use JSON, but you will find some webhooks which are still using kind of a form-based encoding. A form-based encoding is useful for forms if some trigger is happening because of user filling up some data. So then you have some form of event, then you have the kind of the recipient, and then you have to specify what the format is. So with the scenario with the GitHub, the event specification is what? So we have three parties. We have me doing the commit, we have GitHub, and we have the, let's say, Slack channel, okay? So the event is actually what happens on the GitHub side, right? I am triggering the event by doing the commit. The event happens on GitHub. So GitHub has a concept of an event, which is a commit, okay? Another event which may happen on GitHub, what could that be? What you could think of as an event related to GitHub? Yeah? Perfect, exactly. Opening an issue might be another event, right? Closing an issue might be an event. Doing a fork or doing a branch might be an event, right? You can imagine some form of event specifications which will happen on the kind of a sender side, right? So the sender defines some sort of events which will happen, right? In our case, in our assignment 2, the event is adding a new track, right? We decided that we will have a concept of kind of an event of being defined as a new track has been added to the database. That's an event for us, okay? And then what happens? Then we have the recipient side. The recipient side is the one which will kind of consume the event, right? So in the case of GitHub example and in assignment 2 example, the consumer is Discord or Slack, okay, channel. So that's the consumer, the recipient side, and that one defines the format of how the data comes in, right? So if you are a consumer in a form of a text channel on Discord or Slack, what do you need? Well, you need some sort of message, you need some sort of text that you can display on the channel, maybe an icon, and maybe a title, right? So depending whether you go with Discord or whether you go with Slack, you can expect some sort of specification specifying that there will be some sort of title, maybe an icon or a level of the information, and then the actual body, right? So this is the endpoint and the specification for the data to come in. And then the payload is the actual encoding, like how the data is being encoded. Is it JSON or is it a form-based or what is it? And then what happens is the backend system, the sender side, will work, and when the event happens, then the trigger is generated, and then the trigger triggers the hook on the recipient side, passes the data, and then the recipient side does something with it. So in our case, you have a message showing up on the channel, right? So as we were discussing with the clock, it is effectively kind of a form of a trigger that triggers something asynchronously without being because normally the endpoints are kind of called, like the user calls the endpoint. But in this case, it's not the user calling the endpoint, is another service calling the endpoint. And it is asynchronous. It is kind of independent of how the other interactions with the API happen, right? So normally you have some form of API which the users will be using, and you have some sort of webhooks which are offered for automation, for being triggered by other services. It's often used for continuous integration, for those notifications from GitHub. It's often used for notifications that, you know, the continuous integration test failed, and then there is an event. Okay, the test failed. What should happen? An email should be sent, or a warning should be sent, or whatever. Right? You may have a web deployment which pings your website and checks if the website is online. Right? And the moment your website is offline, you won't be notified. You want an SMS to be sent to you that, okay, look, your website is offline, right? And then you go and check why your website is offline. Yeah, by the way, why the website might be offline? Yeah, DDoS, often the case. What else? You forgot to pay the bills and Amazon kind of closed your, disabled your account. Yes, it happened to me too. DDoS, yeah, maybe. I yeah, you didn't pay up for the name service. Yeah. What else? Why? What else may cause the website to be down? Maintenance, exactly. So when you deploy something on Amazon or on Google, it's there and it works, right? It works the first year, second year, and you forget about it. It always works. And then one day they have a maintenance and they have to reboot your virtual machine or virtual service. And then, of course, your website doesn't work because of dependencies, or the browser, the web server doesn't start, or whatever, right? And then you have to go and do manually some adjustments. So it often is the case that because Amazon or Google have to reboot your VM, then some things will go screwed up, right? If you're rebooting it, you can automatically check it. But sometimes it's not you doing it, it's them. And then you kind of screwed. So you have to always make sure that the VMs you're preparing on OpenStack or Amazon or wherever, they actually bootstrap all the services and everything that is needed to run automatically, right? It's worth spending this extra hour or two initially when you're setting things up. Then when you reboot, you don't need to do any manual work anymore. It's kind of automatically MySQL is started, web server is started, and everything works fine. Because if it takes you it costs you no time to reboot your machine and then start 2 or 3 services manually by hand. It's like 20 seconds, and we tend to do that. But it only works if you're next to the console. If the reboot happens kind of independently of you, then you're screwed, because those 3 services that you've been starting manually are not running anymore, right? So you have to think about like automating all the deployment so it can happen without you. Right, so we have an example of integration API services like Zapier or Elastic, which allow you to kind of plug and play different webhooks together. You know, project management, issue trackers, like as you mentioned, opening an issue, closing an issue might be a useful trigger for certain things. Tickers, like trading platforms, if a price of Bitcoin or price of Norwegian krona drops or goes to a certain level, you want either to be notified or you want your bot to sell or buy, right? You may want to automate some of the actions, which, by the way, is often the problem because a lot of traders do that, and then a little bit of market fluctuation triggers like an avalanche of automated trading requests, which then goes out of control, right? So often the market crashes are not done because of the panic, but they are done because of the automated trading, which then generates the panic because suddenly, you know, everybody's selling, right? Well, service monitoring, things being up or down, and so on. All right, so what's the difference between API and webhook? Is a webhook a form of API? It is kind of a form of API, right? I mean, in fact, in the assignment 2, we defined our webhooks as kind of as API endpoints, but the pattern of usage is different. So in one, we do kind of push, and with the other, we do pull, right? So normally, as a user of an API, you polling, right? So you say, I want the data, right? I want to see what happened. I want to get the number of tracks in the database. With the webhook, it's the opposite. Is the backend telling you, you have 16 tracks, right? Not you. It tells actually the notification consumer, which is a Discord, for example, right? So the backend says, look, Discord, I have 16 tracks. Or look, Discord, now a commit has happened. So with API, we have kind of polling, and with the webhooks, we have pushing. So we have pushing and more of a publish-subscribe pattern, right? So with the APIs, we have server provides the functionality, and clients have to poll, right? So if I want to know the current currency conversion between Norwegian krona and euro, I have to ask the service, right? I have to say, okay, what's the current rate? Okay, what's the current rate now? Okay, what's the current rate now, right? With the webhook, I say, please tell me when the value will be between those two ranges, or if the value goes above a particular threshold, right? And then I don't poll anymore. I just subscribe, and I will be told when the particular condition happens. What are the problems with the API? Well, so we have like 3 here, rate limits. So if I want to be updated about the current rate, exchange rate, and I have to keep polling, I'm kind of using the bandwidth, and I'm using the server resources by issuing the requests all the time, right? I may have some timeouts. I may have, we could use webhooks, so we could open the connection and just getting the updates from the line. But then I may have a timeout, or I may have used up all the possible connections which the server can have, keep maintaining open. So what are the problems with the webhooks? What are the possible problems with the webhooks? Yeah, potentially. Yep.
Maybe if you have some sort of client and maybe it's offline when it sends
The notification.
yeah.
Yeah.
Then you turn it back on and you don't know that's
Yeah, you can miss something. Yeah, that's right. So there are those problems like of the actual business logic. There are also problems with security because we have to have some of the things opened. So for example, if you register a webhook with Slack, you will see that you have this kind of an obscure URL, right, which you're not supposed to share with anybody. Why is that? Well, it's that because that obscured part is what makes your webhook safe from other people pushing fake commits, let's say, to your channel, right? Because they don't know this, they cannot guess this kind of a long cryptic sequence of characters. But as soon as this becomes public, then anybody can kind of force fake events into your endpoints, right? So doing kind of a security by obscurity is not ideal, but you know, a lot of webhooks which are based on text messaging kind of do that because the risk of abuse is so low. Like, okay, someone did discovered or the URL leaked. Then what you do? You kind of disable it. Then you generate a new random sequence of characters, right? The damage is not huge, but sometimes it could be. So if the damage could be huge, then you have to make much stronger kind of provisions and security measures. So the obvious one is you will sign your messages in such a way that the server side can trust that the client who was pushing the message is the one which was legitimate, was authenticated to do this, right? So you can do a hash-based message authentication code, HMAC, and what it means is that you have some sort of certificate which allows you to sign the messages on your client side, and then the server will verify that the messages are from legitimate source. That's how a lot of Google APIs work. Yeah. So so the client is the one pushing the message, and the server is the one consuming, right? So the webhook offers kind of an endpoint. So in our case, let's say it's the Discord. That would be the server, right? And then GitHub would be the client, which notifies the Discord that a commit happened. So GitHub would have to sign the content of the message in such a way that once the JSON message goes here, then the Discord checks that the message is legitimate. It's from legitimate source, right? That's right. Yes, exactly. So with signing, message is still visible. It doesn't protect the privacy of the message. It just guarantees that the recipient side can discard messages which are not from legitimate sources, right? It says, no, that's not from GitHub. I'm ignoring that one, right? But again, so if you were to require kind of a privacy over the data, you'd have to encrypt it. So instead of doing a kind of a hash-based signing, you would use some form of encryption, right? Using similar pattern. you can have, like in our case, in our assignment 2, we have this simple browsable webhook APIs, right? We don't actually browse it, we just register it, we look it up, and we delete it, right? We cannot list all the registered webhooks in the spec that we've done. But this is kind of a typical pattern for doing kind of a publish subscribe mechanism with the webhooks. And then if you were to modify it or to browse it, usually you have to have some form of authentication. So the most common one is kind of a token-based OAuth, right? OAuth 2, I mean. So Christopher prepared a simple, yeah, I mean with Go or with JavaScript, in this case, it's very simple to define how to do the HMAC digest, like how to sign some messages before they are put into the content. And this is an example with JavaScript, and there is an example with curl, like how you could do that having the signature. And that was taken from this Elastic.io, which we've used last year. All right, so OAuth is a form of handshake which offers like a third-party authentication for some credentials that you have without passing the actual credentials, right? So in this particular case, let's say I have some resource server. Let it be some image storage solution, right? And I have authorization server. Let's say it's Google. Okay, so if I have an account with Google, I can request access to the resource server, but I don't need to have the resource server managing my my identity. It's Google managing my identity. It's just that resource server delegates the authentication and authorization to kind of authorization provider, right? So they don't learn anything about you other than you've been authenticated by this kind of a third party, right? And that's what OAuth offers. So in this particular scenario, if I'm a user and I have an app which needs an image, okay, then my app asks the authorization server for a token. That token is issued back. I'm trying to access the data with the access token, and then the resource server will verify if the access token was indeed valid and generated correctly from the authorization authority, in our case Google, right? So the handshake happens between you and your authorization provider, and between the resource server and the authorization provider, and then if those two handshakes are kind of correct, then the access is granted, right? So within this request, first of all, you have to be authorized with the authorization server, right? So when you're saying to Google, okay, I want an access token, they say, oh, well, you have to authenticate. So you've either been authenticated before, or you have to provide your credentials to them. And then they can issue you the token which you use here, and then the token can be verified, right? It sounds really simple when you have it on a diagram, and when you actually logically think about it, it's quite simple. But there is multiple stages to it and multiple configurations and so on. So even doing it for manually doing it for a simple OAuth provider like Google is not trivial. If any of you try that, it's like a bit of nightmarish solution, right? There is a lot of moving parts. So normally we use library to do that for us. And most of the OAuth providers or some integrated solutions like the ones offered by Google, they have kind of built-in mechanisms to do that. Because if you were to do those requests, all those HTTP requests yourself manually and do the proper headers and everything, it's kind of a lot of work, and as I'm saying, a lot of moving parts. So there are kind of a client-side libraries which do OAuth for you, and then, you know, if you need to use OAuth, you probably should be using a library instead of implementing everything yourself. Yeah. Okay, so you also have some server-side concerns, which are the problems with scalability or line limiting. So what happens if you have million subscribers for a particular event, and that event happens quite often? Then you have to be issuing kind of millions and millions of webhooks. So you have to kind of think about it, like how will you scale on your kind of event side or on the issuer side, as well as the consumer side. If you are Discord and there is a webhook which kind of is being triggered a lot of times, it floods the channel, right? So what do? Maybe you need to have a line limiter. So you only offer that this webhook is active at certain time intervals. You cannot kind of abuse it. So you have to plan, you know, what can go wrong. And there is a typical kind of life cycle of preparing some sort of a webhook, integrating it with the solutions that you have, deploying it, and kind of monitoring, you know, whether it actually copes with the demands or not. Right, so last year we've used Slack a lot, and also that the webhook integration with Discord was actually not that well supported. We couldn't make the Discord webhooks actually work. This year, I'm pretty sure Discord works fine with webhooks. We've used it before. We've used it with the mobile course. So those of you who want to try with the Slack, that's fine. But because we're using Discord for most courses, and you have your own kind of a Discord channel for the student activities as well, maybe you try Discord, right? So some of the examples which we've used last year are based on this NTNU-Cloud Slack channel. If you want to play with it on the Slack. But if you want to play on Discord, just, you know, create your own Discord server or hook up to one of the ones which we have. To be able to set up the webhooks, I'm not sure, you know, what credentials do you need on Discord. So you may need to have your own. On this one, you can set up your own webhooks and then trigger the events from your app. And we had last year students kind of testing it. I think you can mess up other people's webhooks. So be kind of social and just disable your own ones and kind of configure your own ones. Don't mess up anybody else's. Yeah, it's pretty straightforward. Any questions? So we'll have a 10 minutes break, and then we talk a little bit about JavaScript, JSON, and MongoDB. In the meantime, So this is a video of one of the launches that I've done. So the modern paragliders have three rows of lines, and you have left and right side. And then you have the canopy, and then you have the harness which you sit in. So normally you stand back to the wind, and you have your hands crossed, and then you have canopy in front of you, and then you kind of pull it against the wind like a kite, and then you have to turn around, and then you fly off, right? So here I'm kind of checking the tension of the canopy, kind of standing in front of me, or lying on the ground, and I have the left and right lines in one hand and the back on the other hand. So if I try to lift it and there is a strong gust, I can kind of kill it quickly with the other hand, right? There was my instructor like taking over on the right hand side. Yeah, the camera is a little bit crappy because, yeah. So you turn around, you do a few steps, and usually the wind takes you over, right? So I have a mobile phone which keeps track of the location and all those tasks which I told you about, the triangles and so on. It gives me the altitude, and it also beeps if you're going up or down. And I have the same kind of with the proper variometer. So this is like a professional flying device with much more sensitive sensors, but logically they do the same thing. This one is a little bit faster, right? So for example, if I'm flying and there is a up current, the professional one kind of beeps a little bit faster, right? And then you have two steering lines, the left and right, and you kind of go left or right. So on the right there was the starting spot, which I used to launch. There are some other guys around, and you kind of initially you go next to the hill because the wind kind of pushes the air over, creating kind of like a soaring force. So you can, even without the thermal activity, you can kind of be going back and forth along the hill because the wind kind of the wind goes and it has to go over the hill, so it goes a little bit upwards. And on the edges, you always expect some thermal activity. Like on the edge of the hill, you can find like the up currents, right? So I went quickly to the edge, and then I found a spot where I was like going in circles. So you can see. You pull one of the lines, and you kind of go in a small circle around to use the thermal. And in front of my legs there is a starting point. That's the launch which I used. And then after a while, you get a lot of people around. So you get this one is better. So you have other paragliders around, and it's kind of a three-dimensional puzzle because you have to kind of really keep looking all around because everybody's flying like around you, and some people are going up, some people are going down, some people are going left and right, and it's like it gets kind of intense sometimes. So, and you can see also, so you can see here I was circling around. And then the software tells me where was the highest force pulling me up. So it kind of circles that. And then I can come back to it and find it again and kind of go up. And it's the same with the other one. It kind of marks, blue is where I'm going slowly down, like yellow is going slowly up, and red is like I was going strongly up, right? So you can find some some thermal activity and kind of try to use it. Yeah, that's the city which we stayed in. And then there is yeah, other people kind of circling with me. So there are some rules you have to follow. One of the rules is that you always circle the same way with everybody else. So you don't do this, you kind of do this. The birds do the same. So you're trying to find birds which kind of go up, and then you use them as a marker. Yeah.
How did I get started with doing paragliding?
Well, it was kind of compulsory when I was a student to do sport.
Oh, yeah.
We had a compulsory 2 semesters of sport, and you had like 160 different sports you can pick up, right? And I picked up paragliding as a student. I did my rescue diver as well. And then I did the diving course and so on, because 2 were compulsory, but the other semesters you could take sport if you wanted.
Okay.
Yeah. So it's a very fun sport. And then that's how you land. So that's my friend landing. So you kind of circle a little bit, and then you find a spot, and you kind of going relatively slow. Like if you're going against the wind, you can kind of do it very slowly, and then you kill the wing on the ground. Yeah. So he had good day out as well. All right, back to ground. Mongo. Right. All right. So we talked about JSON before, and you've used JSON encoding, and you get kind of the basic intuition about JSON already, right? So how many of you had SQL databases? Who didn't? Maybe that's the better question. All right, so all of you are familiar with SQL and with tables, right? So you all know that in SQL I have the concept of a table. So let's say I have an age and name, and I will say Bob 21, Alice 25, right? So now I have 2 instances. I have 2 rows. One is Bob, one is Alice, right? If I think about it in JSON terms, what would I have? I would have kind of one object which is says name Bob, and then if it's proper JSON, I have to do this, and then I would have age, and he's 21, right? And then I have to have a second one, right? So if I think, if I were to convert this into JSON, I would probably have to make it an array, right? I would probably have to have name, what was Alice, and then age 25, right? And then close the array, right? So if I were to represent this traditional data structure as JSON, I would probably have to have an array with 2 objects, right? Make sense? Okay. Can I have now? Okay, so let's do this. I have an array with just 1 object. I don't have Alice, and I have Bob. So Alice is not here yet. And then I would say I have name Alice, and I would say age 25, and I would say sex, and I would say F. Right? Can I do this? in JSON? Of course I can, right? Can I do this here? No, I would have to add additional column, right? Can I add another object here, which is, let's say, ID 1 and paraglider ozone. Can I do this? And have an array of 3 objects, one which has nothing in common with the other ones? Yes, I can, right? So you already see that there are some flexibility which I have on this side, which I don't have here, right? So this flexibility is great, and it's kind of very easy to work with, but it has some problems, okay? One of the problems is, so let's say I have this Alice again. I have Alice 25, and I have something there, right? If I get kind of an iterator which goes over the rows of the over my SQL query, right? I can assume that if I is the item that I'm getting, I can always ask for the age, and I can always ask for name, right? Because I have 2 columns, and I can always ask for those 2 properties out of the rows. They might be empty, like I may not have age, but I can always ask for age, right? Whereas here, I actually don't have the schema, right? I don't, if I have an item, sometimes it has ID or paraglider, sometimes it has name and age, right? I'm very flexible what comes here, right? So when I'm dealing with this flexibility, I have to deal with this flexibility in the code, right? The code becomes a little bit more complex because I have to say, oh, is this record which I'm dealing currently the one which has this property? Okay, if it has this property, I do something with it, right? If it doesn't, I have to do something else. So the code dictates, the flexibility dictates the complexity of the code, right? So with MongoDB, which is one of the NoSQL databases, MongoDB uses JavaScript and JSON, and it uses the concept of the collection. So the collection is effectively this array which I have of objects, right? A collection you can think of as basically an array of objects that I have. And the collection has a name. So for example, I can have, and everything you do in Mongo kind of starts with DB. So that's kind of like a root object that you deal with. And then I can have a collection 1, and then I can do some operations on this collection. I can insert a new object into it. I can query the array for objects of certain type, properties, and so on. Right? So the equivalent of a table is a collection, right? But I don't have a schema, right? So here I have kind of an SQL, and here I have no SQL, and the no means I actually don't have schemas. I don't have normalization, I don't have other things, right? And it comes with the cost because I have to make my code a little bit more complex. So because of this, a lot of drivers enforce certain schemas on the underlying collections, right? So you may have a driver which asks you, okay, what sort of objects you will be storing in this collection, right? If I say, okay, I have a collection called students, right? Students, and then I will have name and age, right? Then the driver will enforce that when I'm entering a new object into this collection, it will check, is that object having a name and age properties and no other properties, right? If it has other properties, most drivers will ignore them, right? So if I set up this sex property, but I've declared a schema that only has name and age, then this will be ignored. Once it's saved and restored from the database, this property will be gone, right? So the nature of the database is kind of very flexible and very elastic and kind of flexible. You can do whatever you want with it. But sometimes that flexibility is not what you need. You want some control, right? And that's where the drivers usually, you can make it very strict. and then the driver will enforce that particular collection only takes particular objects, right? But it's not inherent in the database. If you were to manually insert something into the database or do manual queries, you can still do whatever you want, right? Okay, so the equivalent of the table is the collection, and then the equivalent of the database, which is the collection of, let's say, a set of tables, is the set of collections, right? Okay, so that is pretty straightforward. So we have no SQL. We don't have the kind of the formal table-based query language. We have no tables and we have no roles. So we have collections instead of tables. Database is a set of collections. And then collection is a container for documents. So it's kind of like an array of all those documents that we have. Documents are simple structs. They can be nested, right? So I can have a, like with JSON, I can have a struct which has two properties, like what we had here. So I have name and age, but I can also have, so let's have Bob having another property. So I will have name, age, and children. And children is the array of another name and age, right? And now we have kind of a dilemma, okay? So how would you do children in SQL? If I have a collection of, let's say, people, which have name and age, and some of them have children, which are also name and age.
Well, you make another table called children's, and
Yeah.
then the foreign key of the parent will connect the parent to the children itself. So the first column might be the parent ID or something.
Yeah. Yeah. So I would have parent ID, and here I would have a child ID, right? And here I would have some form of unique identifier. And then what I would do here, so Bob is number 1, Alice is number 2, 3 is, I don't know, Tom, who is, Alice was 25, and let's say Tom is 2, and then let's say Bob has Tom as a child, right? And by the way, Alice also, no, that's number 3, Tom is 3, and Alice has also Tom as a child, right? So they are parents of Tom, right? So I will do it this way, right? So the nice thing about this is that I only store the name and name and age in one place, and then I just make the differences. Okay, so imagine that I have a collection of people like we have here. I have an ID of some sort. So Bob is number 1. His name is Bob. He is 21. And then I have his children. I could put the IDs in here, right? I could say 3, right? And then I have my other records, and one of those other records would be ID 3, which is Tom, right? And I would reference Tom as a child of Bob by the ID. Okay. The other alternative is that I put a new object in here, and it has an ID, it has name, and it has age, right? So how Tom was 2, his name was Tom, and his ID is 3, right? I put it like this in here. What's the advantage of doing it this way versus the first way?
The first way, then you have to do some validation with your code to actually get the reference, and this way then you have it straightforward
Yeah. What else is different? So what if I say I want to get names of all the children of Tom or of Bob? Can I do it with a single query? With the first case? Yeah, exactly. You have to search. So usually you have to do one query to search for Bob. You got the document which is Bob, and then you have the array of all the references for his kids, and then you have to do another query to search for those documents which are his kids, right? With this one, when I get the document, I already have his kids, right? You may think, yeah, but then you duplicate the data, right? You have it here. Do you then have Tom here as well? Maybe, maybe not, right? If you have people who have other children, but they are also children of other children, you get kind of a grandparent relationship. Maybe you need to have them here. Yeah.
Yeah. What if you have like Alice there too? Would there be a separate object and the same object Tom under Alice? Because Tom is also a child of Alice.
Yeah, exactly. So if you have Alice here, right, and Alice children, you would have to duplicate that here again, right? You would have it 3 times, right? For Tom, Tom for Bob, Tom for Alice, and Tom as a person, right, who might have his own children, right? Because you don't. Then the question is, nesting of grandchildren. Do you nest them here, right? It gets kind of complicated, right?
And also, if you change one of them, if you change Bob's Tom, will Alice's Tom also be changed?
No, it wouldn't. You would have to do change in multiple places, right? Whereas here, if you want to update Tom now is 3, you update it in one place, right? But if Tom is now 3, you have to update it here, here, and here, right? So it depends, right? It depends on your use case. It's a little bit more thinking of how you organize your data because of the use cases that you're doing, right? So one thing that we've already discussed is integrity of the data. The other one is number of queries, right? If I do it by index, if I just keep indexes, I have to do multiple queries, right? In some situations, you have one choice. In some situations, you have multiple choices, right? So for example, if I have a blog post and I have comments for that blog post, does it make sense to have a collection of comments as a separate collection and collection of blog posts as a separate collection and index the blog with the indexes of the comments? Or does it make sense to have a single document which has the blog post and all the comments as a one document, right? It kind of makes more sense to have it as a one document because each comment will only be child of one of the blog posts. And when you displaying for the client the blog post, usually you're displaying the comments as well. So you just want one query to get the document and render the document, right? But technically you could have 2 collections, right? Another reason for having it as a single document is that we don't have yeah, it's not here, it's on the next slide. We don't have transactions, right? Which is kind of a major problem because what if you have to modify something in 2 places, right? So like, let's say, yeah, it's kind of a contrived example, but let's say Bob now is 22, his son was 2, but his son now needs to be 3 at the same time, like they had birthday at the same day, right? So when you're updating this, you want them either be done at the same time or not done at all, right? Because you want Bob to be always 19 years older than his son. You cannot allow that Bob is suddenly 18 or 20 years older than his son, right? It has to be kind of consistent, right? So you update this to 22 and update this to 3, but it has to be done at the same time. If you don't have it as a single document, like we have it here, I have Bob with his son in a single document, right? Then I have to do 2 updates. I have to update this document and this document, right? But if I don't have Tom as a separate person, I only have Tom as a child of Bob, then I can take this document, update Tom H and Bob H, and put the document back, and I have an atomic change of two data pieces, and I guarantee that Bob and Tom are always 19 years apart, right? It's a stupid example, but you get my point, right? So sometimes if you need this atomicity, you have to make it into a single document because you don't have atomic changes of multiple documents at the same time. We don't have transactions. So anytime you need a transaction, you need to change things in two places at the same time, you have to think of what would be a single document that will kind of consume that change, right? So this kind of allows us more flexibility, but also allows us kind of a little bit of complexity when designing this, right? So with SQL, we usually do this, and then if you want to find Tom's, all Tom's kids, you have to search for Tom, find his ID, search for his kids in the second query, or do a join, right? And then you have the result, and then you render the result. Here, usually, you can organize it that it's just one query, and you get a document, and then you render the document, right? So
what if you want to find someone's parents? You can do that easily in SQL, right? Because you can just look for the ID, but how can you do that in...
that's right. Yeah, exactly. So, for example, in this case, when you have the parent-child relationship and you organize it this way, and suddenly you want, and let's say we organize it this way that Tom is not here, Tom is only as a child, and you want to find parents of Tom, then you kind of screwed, right? You can do that, but it's like a very complex query that you have to get all the collection, all the children, find the ones which match the thing. It's very inefficient, right? So in that case, what you would end up doing, you would end up doing two collections. You would have the kind of a view over who is child of whom, and a view of who is parent of whom, right? And you will duplicate the data, right? So you would kind of have one collection which is like this, and another collection which is from Tom's point of view, having parents as nested things, right? But then, as we were discussing, making data consistent across all those collections is kind of complex, right? But why would you do that? Why would you do one collection and second collection with one being this and the second one from like Tom and then parents and having the parents here? What would be the advantage of doing it this way than doing it with the references, doing it more like SQL-ish way? The price here is that it's harder to make it consistent. That some changes which you've done here are not reflected yet in this collection, so you may get inconsistency, right? The child was born, and then it's been added as a child of Bob, but it hasn't been added here yet. So you cannot find his parents because, or her parents because it's inconsistent, right? But what is the advantage of doing it this way? Yeah, you can find the relation both ways, and you can find what you want with a single query, right? So the piece of information that you need to read is kind of easily findable with just a single query, right? So read access is super fast. You don't have any joins, you don't have any kind of complex queries. It's just one document, you got it, you render it, right? So in situations where you have read-heavy access to the database, and you can deal with a little bit of inconsistencies, this type of databases outperform the SQL-type databases by far, right? So, for example, for Twitter or for Facebook, right? You open somebody's feed, and you have her or his messages, right? You're not modifying it; it's read-only, right? This type of solution is much more scalable and much faster. So you often trade the consistency versus speed of reads. So for situations where the writes and reads kind of balance, and you need much stronger requirements on consistency, SQL databases are still the best, right? If you have transactions, if you have some financial situation where you have to maintain consistency across multiple accounts, Doing it with no SQL database is a nightmare, right? With SQL is much cleaner, much easier. But performance-wise, those type of solutions are much better for read-heavy access, right? Yeah. But again, you pay the price of inconsistency and data duplication, right? All right. So then we have the next slide. Yeah, so we have no transactions. That's what I was discussing. And we have atomic updates and kind of transactions only on a single document level, right? So if you do need to have some sort of atomicity, you have to organize your collections and your documents in such a way that you will be doing it on a single document. Yeah, so I can kind of show you how it looks like quickly. We have 10 minutes. So Mongo. So you have a Mongo daemon, which is the database behind, which actually manages all the requests, and as with MySQL, right? You have a kind of a daemon which runs in the as a service, and then you have the client software, which kind of allows you to do some queries with the database. So if I say show databases, I have number of databases here. I can use student DB. So now I'm using the student DB database. So I can, is it visible? Then I can say,
Was it students DB? Or?
Yeah, that's correct. So I did the typo, and it says, yeah, fine, we're gonna use student DB, right? So if I do show collections, it says you have no collections, right? You have no data. It's very kind of elastic, very flexible, right? Which, as with most scripting languages, is the same. You do a typo, and the system says, no, it's fine. Your variables are new, and yeah. So I have to use students DB. And now if I do show collections, I have a collection called students, right? So now I can say db students dot find one, and it will just give me one of the students that I have in the database. And it says, well, you actually have no students, right? I might have cleared the database before, so let's use something different. Let's use IMT2681, show collections, and I have the assignment 1 submissions from last year, right? So I have assignment 1 collection, so I can do the same as I did before. I can say db assignment 1 find 1, and it will just give me one document from the submission, right? So I have my own test submission, which is I have a student ID, I have my email, and I have kind of a repo URL, and I have a reference code which the students could use to look up their submissions, and so on, right? So if I were to find this doing a query, I would kind of say, find me a document, and then the query language kind of uses the JSON notation, right? So for example, you could say, I want to find a document which has ref code of value W, X, Q, and K, right? And it effectively finds me the same document, right? You can specify the constraints, and then if you do a perfect match, then all those constraints are end, right? So if I would say and the repo URL is something, then it would only find the document which has this ref code and this repo URL, right? It uses AND. If you want to use OR, you would have to say, I want this document, and then you would say something like OR, and then you would specify two documents which have the constraints. If I were to search for a not exact match of strings, and I say a string which starts with something, then you have kind of like a query language which specifies here like again, I would have to look it up and quick. Yes. So if I do Mongo string match, yeah, you can use regex, you can use kind of, it has a built-in query language, which you build by building kind of like a JSON structure, which has, you know, some patterns. So for example, for regex, you would say, I have my field. So as I had here, I would have a ref code, and then instead of actually putting the text of the ref code, you would use like another nested object, which would have this query and then the pattern as a query. So you can build quite a complex queries based on some of those. Yeah. So as I was showing you, you have the OR operator, and you have the various logical and text-based and operators that you use to build your queries, and you have some useful queries. So you can find just one, so it will return you a single document, or you could find multiple if you just use find, and then it will return you an iterator over the answers that you have. A useful thing is that you can assign a return into a variable. So now I'm assigning this JSON into O. So O is now this thing. So if I say show me ID, it kind of shows me the ID of that particular reference that I have. And what I can do is I can say, oh, ref code is now, oops, sorry. So, oh, ref code gives me the ref code, but I can say it's now Baba, right? So now if I display O, the ref code is different. It hasn't been committed to the database yet. To commit it to the database, I would have to say assignment 1, save, and then I would save this record into the database. I would effectively do an update, right? So you can browse and modify your records using the shell, and in similar fashion you can do it from the code. So it's quite easy for debugging. It's quite easy to do. So if I use students DB, and if I say DB students, the collection which I have, show collections. Yeah, I have collections. I have students as a collection. Insert. So now I can kind of insert any JSON I want, as we were discussing. So I can say name Bob. And now if I say DB students find 1, I will have Bob already in. And as you see, I've inserted the object without giving it an ID, and Mongo generated something called _ID automatically, right? It has an ability to generate globally unique IDs for all the objects that you're inserting into a database, and you can use them. They are monotonic. They will be bigger and bigger, so you can sort by them, which means that's because it encodes the location from where the thing was inserted plus the timestamp of when it was inserted, right? Using those IDs as actually public IDs is often the case. So people often who are using MongoDB are using those as unique identifiers for accounts, for objects, and so on. The disadvantage is that you are actually leaking some of the timestamps which were used to create those objects, right? So someone can reverse engineer. If they know 2 or 3 objects, they can reverse engineer and kind of estimate how many you have in the database or whatever, right? But it doesn't really leak any sensitive information. So if you don't care about somebody reverse engineering your timestamps, or if you have timestamp as a public field of your record when the record was created, then you can happily use those as monotonically increasing globally unique IDs. And then, as with the other one, I can, the name O is arbitrary. You can use any name of the variable you want, right? But I can say now OH equals 21. So now O is with name and age, and I can say db students save O. And now if I do again the db students find 1, I will now find Bob with age updated, right? So I've modified the record that I have. Some databases, for example, CouchDB, they keep versions of the objects that you put in. So it will keep kind of additional field. It's sort of like Git. It will remember that the previous version of this document was without age, and now it has age, right? So you can kind of browse the history of the updates. This one doesn't do it out of the box. You can implement it if you want to have the versioning. Yeah, so install Mongo, run the Mongo daemon on your system, play with it like with the command line, browse the documentation of how you do the queries, and then when you'll be building your system like in code, it will kind of be easier for you. Any questions? All right, so that's it for today. And on Friday, we will discuss the peer review and the submission system, and I will post some videos for AWS and for Mongo. Thanks.
And the database driver from Go. That's a bit difficult. Are you going to show how to use?
Okay, I can do it on Friday then. Yeah. Good point.